We were doing some cool tech for the past 2 months, so now it's time for you to hear about it and also get to know what NeoSPCC is up to. This perfect random number generator will help me a little. We're gonna start with the NeoFS department this time. Sorry folks, you'll have to wait for your turn. We have made 4 releases of NeoFS during this time frame, with the latest one being 0.48.1. This number of releases actually suggests that all of the previous work we have done to remove some blockers in the development process that we had with some components and systems that we had and refactored and actually deprecated, it also works. And we have an improved process that allows us to deliver things faster to you and have shorter release cycles. So with these releases, we have seriously improved our get operation performance, primarily for multi-core systems, but also for less powered machines as well, because we have introduced some protocol level changes that make this operation work faster. And also we have shrinked metabases, as we have promised previously, because metabases are also one of the key things for performance in our system if we take the system as a whole. And when they store less data, they fit in memory better and they operate faster, less things to write, less things to read. It all works better. Then also we have implemented some of the protocol changes related to special objects, the lock objects and Thompson objects. They are special in that they do not store any real data, but they are needed for operations, for deletions and locking. So now we have better scheme for them, which will allow us to optimize our metabases in future. Also, we have removed some of the old functionality that no one really uses and that no one really cares about. So we have less cruft in our code base now. We have also adapted our inner ring and storage nodes to work with dynamic block time. Primarily, of course, this is inner ring nodes that were requiring some modifications, but actually a lot less than we were expecting initially before starting this work. But anyway, we have all of the system currently working with this dynamic block time, and I will cover this topic in a little more detail in a subsequent section. One of the big topics we're working on right now is erasure coding support, and this will take us several months, as I have said previously, but we already have some parts of it implemented and we soon gonna be merging them into our main code base, so there is some real progress that you can see in our repositories if you are really interested. Then we are also going to be working on container size estimation improvements. This topic is tied to basic income mechanism and also to some new features that we are going to be implementing, like quoting support. And then we will also be doing some lower level optimizations for get operations and improving our garbage collection scheme. 2 releases of S3 Gateway were made, with the latest one being 0.40.0. Nothing big there, just some minor tweaks, fixes, and API adaptations. And even though we have already merged some PRs after the latest release, they are also relatively minor changes, nothing really big, and we do not expect any big changes there as well. S3 is pretty much stable now. REST Gateway has also went through a couple of releases, with the latest being 0.14.0. Nothing really big there as well, it's even more stable than S3, but some protocol changes and some configuration updates and some fine-tunings and fixing. That's things that we do, basically maintenance of this release. So if you are using a REST Gateway or running a gateway of your own, I know some of you do, so please upgrade. PanelFS Neo.org website was updated to version 0.7.0. This version converts search operations to use Search v2 API via the REST Gateway, of course, and This makes it possible to provide some new functionality for users. So if you have not checked panel.fs.neo.org, go take a look at it at panel.fs.neo.org. It's deployed there with the latest version, of course. We are also going to be updating panel with additional new functionality for things that currently can be done by CLI but cannot be done by panel. So eventually I think we will have panel providing the same or about the same functionality as the CLI. Now moving on to blockchain side of things. In June, we have released NeoGo version 0.110.0. The main feature of this release was a complete NeoFS-based synchronization solution. This approach was outlined in this issue some time ago, and we have implemented it step by step, and currently we have all of this solution implemented in NeoGo, so that we can store and fetch not just blocks, headers like we have done previously, but also state in NeoFS, and we can use it for node synchronization. One little thing that it currently is missing to make it a production-ready solution is trust. Unfortunately, N3 blocks, Neo N3 blocks as we know them, missing any state root data in their headers. This is the topic that was discussed at length in this issue as well. And even though there is a solution for that implemented in NeoGo, the main protocol currently lacks it, because in NeoGo is just an extension. So if you are wondering what we are going to be doing in the next 2 months, that's exactly it. We are going to be transferring these extensions from NeoGo to C# node and making them a proper N3 protocol. So this eventually will allow us to make all of this scheme work not just in test mode, like we can provide this currently for you. You can synchronize your nodes already this way, but it's just not secure. Then it's all going to be provided as a part of the standard node functionality, and it is going to be secure as well. I have previously spent some considerable amount of time here talking about DBFT and its timings. Like relatively recently, I have explained the way we fine-tuned our DBFT library to follow block time more precisely. And then we have switched our FS chains, our testnet and mainnet to 1 second block time. And even before that, we have experimented with ultra-low DBFT timings like 100 milliseconds or 50 milliseconds per block. So you all know that we love DBFT and we love its timings. But one thing that was reiterating over and over again in these discussions is this balance between low block time and high block time. Because when we are using low block time, like 1 second for our FS networks, we have lower transaction acceptance delays, which is good because what you want to do with blockchain is send some transactions, and the faster you get the acceptance, the confirmation for your transaction, the better. But as we get to some low block times like this 1 second block, we also are increasing overhead that's associated with every block we have in our blockchain. We just have a lot of blocks per day, per month, per year that we have to store, process, and deal with somehow. And we also know that many blocks on N3 networks are just empty. That's both for mainnet, testnet, primary networks, and also for FS chain networks, especially there, because there is not a lot of activity there the way it's currently used by inner-ring nodes. This activity actually usually comes in some spikes where we have some number of transactions sent in some short amount of time, and then we have a long period of time where nothing really happens. So here comes the idea of dynamic block time. What if we could have blocks that are sometimes 1 second blocks and sometimes like 20-second blocks depending on the way network is loaded or not. This idea is not exactly new. It was discussed previously, but there was no practical proposal for dealing with some problems associated with the way this network functions. Now there is one. And this proposal was implemented in Go DBFT library 0.4.0, which is included into NeoGo version 0.111.0 and is available for you to use currently. This is the NeoGo extension currently. Testnet is already using this extension with minimal block time set to 1 second and maximum to 20 seconds. And by the time this episode is published, mainnet is going to be using this as well. But while this works for FS chains, it cannot be immediately transferred to mainnet because there is some logic in the node that depends on this relatively stable block time, even though it was never perfect due to change views or various other network conditions. But still, gas production assumes that blocks are relatively stable in time because gas production is tied to blocks, and even though if you are to change block times pretty randomly, you can say that it's the same in blocks, but people are usually expecting it to be more or less the same in real time. These issues can be solved, and the solution is already outlined in this issue, but we are not going to tackle these problems immediately because if it works for FS chain networks, it's good for us already. But if you are interested and if you want to drive these topics forward, patches are welcome, as usual.